Welcome to Cosmic Whispers, where cosmic mysteries come alive. Your journey beyond the stars begins now. What if I told you that for centuries, we've been gazing up at the night sky, wondering if we're truly alone, and only now are we starting to uncover the answers? What if the technology we've created could give us a glimpse into the farthest reaches of space, allowing us to witness something we've only ever dreamed of, an actual image of a distant planet? Well, that moment has arrived. Scientists have just unveiled the first ever direct image of a distant planet, a revelation that has stunned the scientific community and reshaped our understanding of exoplanetary systems. The gravity of this discovery cannot be overstated, as it marks a pivotal moment in our quest to understand the vastness of space. For centuries, humanity has wondered if there's life beyond our own planet. Ancient civilizations gazed up at the stars, weaving myths and stories about the cosmos, but it wasn't until the 20th century that we started to peer deeper into the universe with the help of telescopes. Even then, we were only able to observe distant planets indirectly, using methods like the Doppler effect or the transit method, which allowed us to infer the presence of exoplanets by observing their effects on their parent stars. But we've never had a direct look, until now. Enter the James Webb Space Telescope, JWST. Launched in late 2021, this telescope represents the next giant leap in our ability to explore the cosmos. With its unprecedented resolution and infrared capabilities, the JWST has been designed specifically to look deeper into space and further back in time than any telescope before it. It's a technological marvel that has already begun to unlock secrets about the early universe, star formation, and now distant planets. In the past, capturing a direct image of an exoplanet was like trying to photograph a firefly in the middle of a stadium packed with floodlights. The brightness of the stars makes it almost impossible to see the dim light emitted by planets orbiting them. But the JWST has special tools that allow it to block out the blinding light of stars, enabling scientists to capture clear images of the planets themselves. This is exactly what happened with this historic image, the first ever direct photograph of a planet orbiting a star outside our solar system. The planet in question, named HIP 83120b, is a gas giant located approximately 320 light-years from Earth. While it's too far to reach, the image it has provided us is a snapshot of what could be a whole new world waiting to be understood. HIP 83120b is massive, more than 10 times the size of Jupiter, and it orbits its star at a distance closer than Mercury orbits the Sun, making it an intriguing subject for study. But why does this discovery matter so much? To truly appreciate the significance, we have to understand what this image represents. For years, scientists have speculated about the potential for habitable planets, planets that could host life. But until now, we've only had indirect data to guide us. Now, with the ability to directly capture images of exoplanets, we can study them in ways we never thought possible. This includes examining their atmospheres, identifying the chemical compositions of the air, detecting signs of weather patterns, and potentially even looking for the kinds of molecules that could indicate biological activity. One of the most exciting aspects of this discovery is how it opens up new possibilities for future exploration. The JWST is just getting started. As more images are captured and more planets are studied, we will gain a deeper understanding of the types of planets that exist in the universe. Are they similar to Earth? Are they hostile, barren wastelands? Or could they be teeming with life? The data we gather will be invaluable in determining whether Earth-like planets are common or rare, and whether the conditions for life are found elsewhere in the cosmos. And there's something else that makes this moment truly thrilling: the implications for future space exploration. With the JWST able to provide direct images of distant planets, we might be able to detect signs of habitability, or even signs of life itself, eventually opening the door to missions that might bring us closer to other worlds. Could we one day visit these distant planets? Could we one day establish contact with other civilizations? For now, these questions remain unanswered, but they're more tangible than ever before. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. Now, let's dive into the specifics of the technology behind this breakthrough and how scientists were able to capture this incredible image. Imagine a camera so powerful, so precise, that it can capture the faintest details of a planet that's hundreds of light years away, despite the blinding glare of its star. It sounds like science fiction, but it's exactly what the James Webb Space Telescope has made possible. To understand just how remarkable this achievement is, we need to delve into the heart of the technology that made it happen and the challenges that had to be overcome to make this image a reality. The JWST is unlike any telescope we've ever built. It's a marvel of engineering, designed to peer into the infrared spectrum, which is crucial for observing objects that are too far away, faint, or obscured by cosmic dust. But infrared light is not something our eyes can detect, and capturing it requires specialized instruments, one of the key innovations that made this direct image possible. First, let's talk about the telescope's primary mirror. This is the largest mirror ever launched into space, measuring over 21 feet across. To put it into perspective, the Hubble Space Telescope's mirror is just 8 feet wide, so the JWST's mirror is nearly 3 times larger, giving it a far greater ability to collect light. But size alone doesn't guarantee success. The mirror is made up of 18 hexagonal segments, each coated with a thin layer of gold to enhance its ability to reflect infrared light. These segments had to be precisely aligned in space, and they were. The result is a mirror that can capture an unprecedented amount of light from faint objects deep in space. But capturing light is only the first step. The real challenge comes in separating the light from the star from the light from the planet itself. Stars are incredibly bright, and they tend to drown out the faint glow of planets orbiting them. This is where a key technology, called a coronagraph, comes into play. The coronagraph acts like a cosmic sunglasses filter, blocking out the light of the star, while allowing the light from the planet to pass through. With this tool, the JWST was able to isolate the planet's faint glow and capture its details in stunning clarity. But it's not just about blocking out light. The JWST also has an advanced instrument known as the near-infrared camera, NIR-CAM, which is designed to capture images in the infrared spectrum. The infrared light emitted by distant objects often reveals hidden features that would be invisible in visible light, such as the chemical composition of a planet's atmosphere or the presence of heat from its surface. This is crucial for studying exoplanets, as it allows scientists to determine things like temperature, composition, and atmospheric properties, clues that could one day help us identify planets that might support life. However, capturing such a delicate image requires more than just the right instruments. It requires precision on a level we've never seen before. The JWST operates from a location in space known as the second Lagrange point, or L2, which is nearly 1 million miles from Earth. This location allows the telescope to stay in a stable position relative to the Earth and Sun, providing a constant view of the same part of the sky. But being so far from Earth also presents a challenge in terms of communication. The data captured by the telescope has to be transmitted back to Earth at the speed of light, which can take anywhere from a few minutes to several hours depending on the distance. This means that every image captured by the JWST is a result of painstaking planning and real-time adjustments, with scientists on Earth working in near-constant communication with the telescope to ensure the best possible results. The sheer complexity of the JWST's instruments and the precision with which they must be calibrated is mind-boggling. But when everything falls into place, the results speak for themselves. And that's exactly what happened with the image of HIP 83120b. The team behind the mission was able to capture a stunning photograph of the planet, providing us with our first ever direct visual evidence of a distant world. As we look at this image, it's easy to forget just how many years of research, development, and collaboration went into making it possible. The journey from the concept of the JWST to the first images it produced was long and fraught with challenges, but it was all worth it. The excitement in the scientific community is palpable because this image is not just a pretty picture, it's a new frontier in our understanding of the universe. So what's next? With the JWST now operational and producing images like this, we're standing on the precipice of a new era in space exploration. Future missions will continue to build on this foundation, pushing the boundaries of what we know about distant planets, their atmospheres, and the potential for life beyond Earth. The JWST is just the beginning. Who knows what other secrets lie hidden in the depths of space, waiting to be revealed by this extraordinary telescope. Every discovery leads to more questions, and that's what makes the exploration of space so endlessly fascinating. The more we learn, the more we realize how much there is still to uncover. Now that we've seen how the technology behind this image works, let's take a deeper look at the planet itself. What does HiP 83120b tell us about the kinds of worlds that exist beyond our solar system, and what does it mean for our search for life? Now that we've explored the groundbreaking technology behind the James Webb Space Telescope, let's turn our attention to the star of the show, HiP 83120b. While the excitement over this discovery is still fresh, the implications of this planet's characteristics are vast, and they may hold answers to some of our most pressing questions about the universe. HiP 83120b is a gas giant, a massive planet with a thick atmosphere. Composed primarily of hydrogen and helium, similar to Jupiter and Saturn. But don't be fooled by its familiar classification. This planet is nothing like anything in our solar system. It's a world that orbits its star in a way that challenges many of the assumptions we've made about exoplanets and their formation. First off, HiP 83120b is located much closer to its star than any of the gas giants in our solar system. It orbits its star in just 4.5 Earth days, far quicker than Jupiter, which takes nearly 12 Earth years to complete a single orbit. And this proximity to its star means that the planet experiences intense heat, with temperatures reaching over 1,000 degrees Celsius. That's hot enough to vaporize metals. In fact, scientists believe that if you could somehow land on the planet, you'd be greeted by a thick, swirling atmosphere of gas, clouds, and scorching temperatures, conditions that would be impossible for life as we know it. Despite its inhospitable environment, HiP 83120b offers us an opportunity to study the effects of extreme proximity to a star on a planet's composition and structure. The planet's atmosphere is likely to be under constant stress due to the intense radiation from its nearby sun. This makes it a perfect candidate for studying the phenomenon known as atmospheric stripping. In such conditions, the heat from the star can slowly erode a planet's atmosphere over time, causing it to lose precious gases and materials. This process has important implications for how planets form and evolve in different environments. But there's more. As we observe the planet in greater detail, we begin to see how its environment is shaped by this close relationship with its star. One of the most fascinating discoveries is the way the planet's atmosphere is likely divided into two distinct layers. Scientists hypothesize that one layer is dominated by high-altitude clouds, while the other consists of deeper, hotter gases that could reveal clues about the planet's internal structure. This sort of atmospheric layering is not something we've seen in detail before, and it could help scientists understand the complexities of planetary atmospheres on a much deeper level. What makes HiP 83120b even more intriguing is the fact that we're seeing it through the lens of the JWST's infrared capabilities. The telescope's ability to capture infrared light is crucial because it allows scientists to study the heat signatures of planets, revealing the temperature and structure of their atmospheres. In the case of HiP 83120b, this means we're able to see not only the planet's surface temperature, but also the thermal patterns in its atmosphere. Scientists are particularly interested in understanding how heat is distributed across the planet's surface, whether it's evenly spread out or if there are significant hot and cold spots. This information could tell us a great deal about the planet's weather systems and how they behave under extreme conditions. The image captured by the JWST also allows us to study the chemical composition of HiP 831.20b's atmosphere in unprecedented detail. The presence of certain molecules like water vapor, methane, and carbon dioxide could offer valuable insights into the planet's formation and the possibility of life. Although this planet is not a candidate for hosting life as we know it, the data we gather from it will be critical in understanding the conditions that make planets habitable. By studying planets like HIP 831.20b, we can refine our search for planets that are more Earth-like and possibly more hospitable to life. HIP 831.20b is also part of a larger class of exoplanets, known as hot Jupiters. These massive gas giants are common in the universe, yet their close proximity to their stars and the extreme conditions they endure make them strange and fascinating. For scientists, they provide a unique window into planetary formation processes. We've discovered hundreds of these hot Jupiters, but each new one brings new surprises. What's remarkable is how quickly we're able to uncover these details with the power of the JWST. It's a new era in exoplanet exploration. But perhaps the most exciting takeaway from this discovery is the potential it holds for our broader search for habitable worlds. As we continue to study planets like HIP 831.20b, we'll gain more insights into the factors that contribute to a planet's habitability. We might not find life on this particular gas giant, but every piece of data we collect helps us better understand what makes a planet suitable for life. It's like piecing together a cosmic puzzle, where every discovery, no matter how small, brings us closer to answering one of humanity's most profound questions. Are we alone? As scientists analyze the image of HIP 831.20b, they're not just looking at a planet. They're looking at the potential future of space exploration. This image is a roadmap for how we might explore other exoplanets in the future, using the JWST to peer deeper into the universe and answer the questions that have fascinated us for centuries. The data we're gathering now will lay the groundwork for future missions and discoveries, some of which may change the way we see our place in the cosmos. The excitement is just beginning. The JWST is only getting started, and with it, we're on the verge of unlocking some of the deepest mysteries of the universe. Now that we've examined the planet itself, let's turn our attention to the bigger picture. What does this discovery tell us about the broader search for life in the universe? Are we closer to finding planets that could actually support life, or is that still a distant dream? As we stand on the threshold of this new era in space exploration, one question looms larger than all the others. What does this discovery mean for our search for life beyond Earth? The first ever direct image of HIP 831.20b is not just a technical achievement, it's a beacon for the future of space exploration, offering new insights that could lead us to answers we've been searching for centuries. While HIP 831.20b is an inhospitable world, its discovery provides us with the tools and techniques that will help us identify planets with much more potential for life. This image is part of a broader trend in which humanity's technology is rapidly advancing, enabling us to peer deeper into space and gather information that was once beyond our wildest imaginations. The James Webb Space Telescope has already begun to deliver findings that will shape the future of exoplanetary science, and this is just the beginning. When we look at a planet like HIP 831.20b, it's easy to think about how alien and hostile it is. After all, it's a gas giant that exists in extreme conditions, far from anything we would consider hospitable to life. But it's precisely this kind of planet that holds valuable information. Each new discovery, no matter how distant from Earth-like conditions, expands our understanding of planetary systems. With every new image, we learn more about the variety of planets that exist in our galaxy and how they form, evolve, and interact with their stars. In the case of HIP 831.20b, the most significant takeaway is the way it challenges our preconceived notions about where habitable planets might exist. We've often assumed that life could only thrive on planets that resemble Earth, rocky worlds with liquid water in the so-called habitable zone around a star. But as we see with HIP 831.20b, planets that are vastly different from Earth can still offer us incredible scientific insight. And they give us hope that Even if life can't exist in places like these, it could very well exist on other Earth-like worlds yet to be discovered. The image of HIP 83120b is a catalyst for pushing the boundaries of how we define habitability. We are learning that the conditions for life might not be so simple, that life could potentially exist in environments we once thought to be too extreme. As we continue to gather more data, we will refine our search for planets that meet the key conditions for life. Perhaps future discoveries will reveal planets with atmospheres that are more Earth-like, and in those atmospheres we might detect the chemical signatures of life itself, signs of biology in action detectable from millions of light-years away. Insane. Fact. Some scientists believe that we may already be on the verge of detecting biosignatures, the telltale signs of life, in the atmospheres of distant planets. The techniques used to study exoplanet atmospheres, like the ones we've seen, with HIP 83120b, allow us to look for specific molecules that are associated with life. Oxygen, methane, and ozone are just a few of the potential markers that could signal the presence of biological activity. While we're not there yet, the potential is real. As technology advances, we may one day look at the atmosphere of a distant world and say, "This is it. This planet has the ingredients for life." The discovery of HIP 83120b, then, is more than just a milestone in space exploration. It's a reminder that we are part of something much larger than ourselves. The universe is vast, and while our corner of it may seem insignificant, the search for life out there is a reflection of our innate curiosity, our desire to understand our place in the cosmos. Every new image, every new discovery brings us closer to answering the question that has defined humanity for centuries. Are we alone? With the JWST continuing its mission and more discoveries on the horizon, the next few years promise to be filled with revelations that will push our understanding of space to new heights. The telescope's ability to study distant planets in such detail is opening doors we once thought were locked. With each new image and piece of data, we are not just learning about distant worlds, we are learning about our own. But here's the most exciting part. We're not just observing from a distance. This is the beginning of a new chapter in human exploration. The more we discover, the more we can build on this knowledge. Perhaps one day, future generations will travel to these distant worlds. They might walk on planets beyond our solar system, or they might discover signs of intelligent civilizations that share the same yearning for discovery. The search for life isn't just a scientific endeavor, it's a deeply human one. So what does the future hold? The first image of HIP 83120b is just the beginning. We are standing at the edge of a new frontier where the possibilities are as limitless as the stars themselves. As we continue to explore the universe, let's remember that every discovery, no matter how small, brings us closer to answering the ultimate question. As we peer deeper into the cosmos, what other hidden worlds will we uncover? What other secrets lie just beyond the reach of our understanding, waiting to be discovered? We can't wait to continue this journey with you. If you're as excited about the mysteries of the universe as we are, don't forget to like this video, share it with fellow explorers, and drop a comment below. Tell us what you think about this historic discovery. The universe is full of wonders, and the adventure has only just begun. Let's explore it together.